Now we've calculated our first model, we can start interrogating the results in detail. We can inspect the results for each component in the Results tab, which can be found on the data palette here. The result fields displayed reflect the component which is selected on the flowsheet and will update automatically as we select different components. For example, these results represent this pipe on the flowsheet. If we select a pressure boundary, you can see that the visible results are quite different. Let's go back to the pipe element and look at the results in detail. It's possible to select exactly which results are displayed in the Input tab. To modify your view, simply right-click on the palette or on the flowsheet and select Visible Results. Alternatively, you can use the F8 keyboard shortcut. We can now check or uncheck the available results that you want to be displayed. You can specify this for specific elements, whole groups, for example all pipe components, and all elements in the database. You can also use the Clear button to clear your selection if needed. Now we have the results that we want visible. Let's have a look at them in more detail. We can see the flow rate through the pipe, the friction loss in that pipe, and also confirm the loss correlation that was used in the calculation. The next two results, economic velocity and economic size, are very important and offer an effective tool for pipe sizing. We'll discuss them in detail in video 6. Next we come to the actual pipe size, which is the inner diameter of the pipe used for friction loss calculations. And finally the fluid phase. Fluid Flow 3 will track the fluid phase throughout the network and detect flashing or condensing which would lead to a change in state in phase. The next set of results report the relevant fluid properties in the pipe and are reported at the start of the pipe element, denoted by the in property, and at the end of the element, denoted by the out property. So for example, we can see the stagnation pressure at the start of this pipe is 301.42 kPa(g), and the pressure at the end of the pipe is 65.10 kPa(g). The difference between the two should equate to the friction loss in the pipe. Let's check with the calculator. You can see that the results match. We can see there's no velocity change because we're using a liquid. In a gas system like this one, however, you can see that the gas accelerates along a pipe. Fluid Flow 3 uses a complex algorithm for solving gas networks. It splits each element into sub-elements of varying length based on the rate of change of density in the pipe. This ensures that we get more calculations happening when the changes are taking place more quickly. Other properties we can see here include viscosity, temperature, again there's no change because we currently have heat transfer turned off, and density. We can also see the Reynolds number for the pipe and the calculated friction factor. Let's select a different node, say this pressure node here, and you can see that the Results tab is updated to only report results relevant to that node. A quick note on pressure definitions. Stagnation pressure includes both the static pressure and the velocity pressure component of the fluid. In other words, this would represent the pressure at the static boundary layer between the fluid and the pipe wall. Now let's look at the function of messages in Fluid Flow 3. You can see 3 pipes in the flow sheet are highlighted in red. This means there are warnings or errors associated with them. You can find details of these warnings on the Messages tab, which can be found here. Clicking on the warning highlights the relevant component on the flow sheet. You can see the warnings displayed here relate to the flow in the pipe wet network. We can also see a description of the warning down here. In one pipe we have a high velocity, while in the other pipes we have a low velocity. If we flip to the Results tab for this pipe, for example, we can see a velocity of 6.42 meters per second, which is much too high for most water systems. The limits for these warnings can be set by the user by navigating to Options, Warnings and Hints. From these tabs you can set the limits for liquids, gas flows, and two-phase flows. It's important to note that unless otherwise specified, a warning is simply that. The model has still calculated accurately and the results are correct. As we will be looking at pipe sizing in video 6, we won't worry too much about correcting these velocity warnings just now. Finally, let me show you how to select the display units for your results. FluidFlow 3 allows you to change the selected results units without having to recalculate by simply right-clicking on the flowsheet and selecting results units. Or you can press F9. From here you can select your required units and also specify the number of decimal places you would like to see them reported in. Let's change our flow to litres per second and also the terms of our pressure and head drop. Simply make your changes and click OK to accept. You can see now our result units have been updated, both on the flow sheet and on the Results tab. In our next video, we'll look at how you can customize your experience by exploring the use of environments and other options.